Fine. Good evening. In the previous class, we have completed the core topics on manufacturing, and we are left with some other topics, but I'm not going to discuss now. We are going to complete industrial first, and then we are going to come back with some other topics of manufacturing. So, what are we left with? We are left with metrology inspection and material science, and those are very what you say uh, the weightage of that topics are not very high in GATE. Maybe they are having good weightage in HL exam. We don't know that. But what I feel is that we have completed 4 important topics of manufacturing. Those are metal casting, metal forming, metal cutting, and joining process, right? And these are very important and core syllabus in the manufacturing. The other two are metrology inspection and material science. Those are some kind of topics where the weightage is a little bit less compared to these 4 topics, what I mentioned already. And the next important topic, the important topic that we are going to discuss today is industrial engineering. So we are going to start industrial engineering today, and we'll be discussing industrial engineering and completing the industrial engineering first, and then we'll be discussing about the miscellaneous topics that are left in the manufacturing section. Okay, so today we are going to discuss uh, industrial engineering. So this is the syllabus for industrial engineering in the GATE, right? So we have production planning and control. In that we have forecasting models, aggregate production planning, scheduling, material requirement planning, all these things we have in the production planning and control. And we have inventory control. In that we have deterministic models and probabilistic models. Probabilistic models are also known as safety stock inventory control systems. We'll see why. So what is the difference between deterministic and probabilistic? Why probabilistic models are known as safety stock models? All these things we'll see. And next important topic in industrial engineering is operations research. In operations research, we are going to discuss linear programming, simplex method, transportation, assignment, network flow models, simple queuing model, PERT, and CPM. Okay, Praveen is saying, sir, are you saying, Praveen, that you're traveling and you may not be able to respond in chats? What is that you're saying, Praveen? I'm not getting it. Okay, fine. You are saying that you won't be able to respond in the chat. Okay, fine. No issue. Fine, fine. Carry on. But you can listen to me, right? You can listen to me. That's okay. Fine. Very good. Fine. Now let's go and okay. This is GATE syllabus, weightage, and all. So these are the topics that we are going to discuss in industrial engineering, and these are some books that you can refer for industrial engineering. But now we don't have much time. Already we are in the mid March, and I think in the first or second week of April we have examination of HL. So let's not touch any book as of now. If you want, you can take a snapshot of this, and you can read this thing in your further preparations if you are doing, right? So these are the good books that I think I didn't refer this book, Industrial Engineering and Production Management. I didn't read this book, but the other 3 books I have referred. This P.K. Gupta, this Taha, and the Khanna. I've referred these 3 books, but this book I haven't referred. But people suggested me that this is also one of the good books. So that's the reason why I have put in the references here. Fine. Now, fine. So first we have to know what is the difference between a production manager and a industrial engineer. But before that, we have to know what is the difference between production and production system, right? So if you are seeing here, production, we have already defined this definition in the first initial slides of our manufacturing, right? When we have discussed about introduction of manufacturing, then we have discussed, right? It's nothing but converting raw material into finished good. Fine. Now, what is input? Input is your raw material, your machine, material, your manpower. All these things are the inputs for your all these things are inputs in your production, and then you're using that inputs to convert using some, what is this conversion process? The conversion process is manufacturing process. From manufacturing process, we are going to output. And what is output? Output is nothing but the finished good. Okay. So that is what we have discussed in the initial slides of our manufacturing. Next, what we are discussing, production system. Production system, right? So it is full organization now. Here it is like only producing. Like here you are having complete system. It's a full system in the sense it's a full company, right? It's a full company. The company needs so many things. Here you are saying input simply raw material, output finished good. That's okay. But here inputs are material, manpower, machine, energy, money, information, everything is important. Right? Then you have conversion process, you have some scheduling, right? You have some sequencing, you have so many things. And then you have output. After output, you're having some inspection process, and then your inspection is comparing the original one. And then if there is an error, that error is sent to the inputs by feedback. So that is what is the difference between production. Production is a very loose term. Production system is complete organization. That is what is the main difference. Okay. Next. So what is the difference between an industrial engineer and a production manager? So if you see here, the objective as an industrial engineer is concerned with design, installation, and improvement of production system. Improvement of production system. Here it means that you're trying to optimize the system. So production is having some technicalities. Technicalities in the sense we are a mechanical engineer. So we are mechanical engineers. So what we are going to do? So we are going to convert the raw material from we are going to convert raw material by using manufacturing process to finished good, and it should be maintaining its good surface finish, right? Proper dimensions, good accuracy, precision. All these things are very important. So technically, a production manager will be responsible for seeing the quality and quantity. How much people, how we are going to do, which tool we are going to use, right? And how much depth of cut has to be given, how much feed has to be provided, right? If there are some mechanical vibrations to the machines, what are we going to do? Whether tool has been failed or not. So if tool is wearing fast, let us see what is the problem in that. Right, so we are seeing mostly quality of the product and quantity. Quantity also is very important because a production manager has to complete his task saying that today the deadline is that we have to manufacture some 25 to 30 parts from morning till evening in certain machine. So he has to track that. That is very important. If you are an industrial engineer, it's not about a single machine or a single bay. Right? If you see a bay, like this is what is bay. It's called bay. So you have machine 1, machine 2, machine 3, all these things. If you have visited a manufacturing plant, then you might have seen this kind of things. What is that? You have machine 1, machine 2, machine 3, and there is a person working on each machine, if you see, right? And each person is having shift, right? You have 8 hours of shift, day shift, night shift, general shift. There are so many shifts that are run in India, right? So in this bay, this guy, production manager, has to check, okay, I'm responsible for this bay. What I do, I will see, let's say in that machine 1 is turning, machine 2 is milling, machine 3 is drilling, let's say. So on how many parts have to be turned, how many parts have to be milled, how many parts have to be drilled, that is what he has to check. And if there are any same technical issues, then that person has to rectify them. And also he has to undergo in this routing system. Routing in the sense like the material has to turn first, then mill, then drill. Everything has to be taken care by production manager. He is very responsible for that. If you are an industrial engineer, you're not going to care about whether turning is done first, milling is done first, drilling. You're not going to care about it. But you're going to see with minimum resource, with least amount of time, I want to maximize my company profit. I want to produce more. I want to get good profit. Profit is important term here. I'm going to optimize everything here. When it is going to come. So if let's say if this part has to come to this point by 8 o'clock in the morning, let's say. So what are all things that I have to do before so that everything is on time? How to increase the productivity of work, the work environment, right? All these things are very important aspects of industrial engineer. You got to optimize things. You are going to act like a management student rather than a mechanical engineer. But if you're alone reading the management, if you're not knowing the technicalities, you can't do that, right? So that's the reason why actually operations research, this all these things are even in MBA. If you're doing an MBA or BBA, you kind of find all these things. But we are going to apply those concepts into production plant. That's the reason why this is called industrial engineering, right? So we have to have domain knowledge. We have to have knowledge of machines, material, manpower, tools, materials, all these things. If we have knowledge, then we'll be able to efficiently optimize the things, right? That is what is the main difference between an industrial engineer and a production manager. In a loose term, industrial engineer will try to optimize things. Production manager will see all the technicalities and he'll try to concentrate on quality and quantity of the materials, the quality and quantity of the work which is produced. That's it. Fine. Now, the first topic that we're going to discuss today is inventory control. Okay. So before discussing inventory control, I'll ask you one question. So there are so many examples here. This and all is there. Don't forget about that things. Take any item in your. So now what I'm going to do is that, if I say example of if I take example of real manufacturing product, it might be a little bit boring to you, right? So what I do first, I'll take some generic example, then I'll relate it to the manufacturing perspective. Okay. So what I'm going to do is that, let's say you go to grocery shop and you buy some quantity, some products, like if you're going to take some vegetables, or if you're buying some groceries, if you're buying some your healthcare, like lotions, face powder, oil, all the things you're going to buy in one time. You're going for shop and you're buying it for one time, and you're going to use it for 1 week, maybe 10 days, maybe 15 days, maybe 20 days, sometimes even for 1 month also you'll buy. Isn't it? Yes or no, guys? You're not going to buy only for that day itself. You can't go and ask for half soap. One soap is enough for me. One small body lotion is enough for me, or maybe 1 cup of dal is enough for me. You're not going to buy like that, right? You're going to buy in lump, and but for that lump there is a limit. You're not going to buy some 100 soaps. You're not going to buy some thousand kgs of dal, 10 packets of salt. You're not going to buy. You're going to buy, but there are some reasons. But generally, if you're going, so you're going to buy less for some reason. You're going to buy more for some reason. Why you're going to buy less? Because if you're in a traveling mode, you don't want to carry more, so you buy very less. If some function is there, you're arranging some function in your home, and then you want to feed some 100 people, then you're going to buy. That's different scenario. But generally, what you do, you buy some quantity with some limit on that. 1 kg of dal, 1 coconut, 2 kgs of tomato. Like that, you will buy all these things. Why? If you are buying more, what happens? If you're buying more, they'll get damaged. If you're buying less, again tomorrow you have to go. So here, if you take the example of soap, let's not go into all the components, all the items. Let's say simple example of soap. Very, very simple. Generally, I feel that, so this, the date is like this date. What is that? 5th August 2021. Let's say, right? I'm going to buy 12 soaps, and the first day itself I'm gonna open first soap, and the 11 soaps I'm putting in a store, and whatever the soaps that are there in the store is known as inventory. What is that? Inventory can be termed as stock on hand at a given point of time, which you have for later purpose or sale. You can, if you are using it for personal use, then it is later use. If you are in a shop, if you are in a wholesale shop, or if you are the owner of a grocery store, then you are going to sell that, right? So that is what is inventory. You want to save some stuff or some components, some manufacturing. In manufacturing also, you're ordering raw material, you're ordering some raw material, some, let's say if you're ordering some slabs of some certain dimension LBH, there are some 30 or 40 slabs that you're ordering from some foundry section, and you're not going to manufacture all that 40 slabs in a single day. What are you going to do? You're going to use, you're going to manufacture 10 today, tomorrow 10, day after tomorrow 10, like that you're going to manufacture, but you're bringing all of them together, you're buying all of them together, right? Because every time, but today you'll buy, tomorrow again you can't go and order, again day after tomorrow you can go and order, like that you can't do, right? So the important thing here is that, okay, I'm keeping some amount of products in my store, but how many products, how many products I have to store, how many products I have to store? That means inventory control means making the desired item of required quality and required quantity available to various departments when needed. Quality is also important. Okay, sir, suddenly I'll buy some 100 subs and keep in my garage, in my whatever cupboard. I will use it throughout the year. Did you even care about seeing the expiry date? It might happen that after 6 months the expiry is happened over. So out of 100 soaps you have used 50 soaps and 50 are waste. Where is the quality? Quality is lost. Quantity is there, but quality is lost. So you have to take care of quality and quantity as well, right? So let's discuss more on this with the coming slides. Fine. So in inventory, the important things are costs, because neither you can't buy more nor you can't buy less. There is an optimum quantity. Why? What is that optimum? What you're optimizing there? You're trying to optimize the cost. Optimizing means minimizing the cost or maximizing the profit, right? If you're minimizing the cost, what do you have to do? You have to know what are all the costs those are associated with the inventory. So if you're seeing, these are the four different costs. 1, 2, 3, 4. These four different costs are associated with inventory control. Inventory cost. What is the first cost? If you see, the first cost is purchase cost. Obviously, if you're going to buy soap, let's say that each soap is of 40 or 50 rupees, let's say, and in one go you're buying some 12 soaps. You have seen 12 soaps, right? So 12 soaps into 50, you are spending 500 rupees. How many is 12 into 5 is 600 rupees per purchase cost for buying 12 soaps. Number of units purchased 12, cost per each item 50 rupees. So understood, right? So 12 soaps into each is 50, you're going to buy 600. This is your purchase cost is, okay. Ordering or setup cost. What is ordering or setup cost? Let us assume two scenarios. One is you are going from your home and you are buying it. This is your home. You are, sorry, let me draw like this. This is your home, and this is your grocery store, and this is some Amazon warehouse, let's say. If you are going and coming back and buying some stuff and coming back, it means that you are spending some money on transportation, right? Maybe petrol and all the things, and your transportation plus some time you're spending. Time you will leave it, but transportation cost is there. So in a way, you're trying to spend some money to buy that stuff, right? Or else, let's say you ordered online. If you're ordering online, you have some ordering cost. That is what is known as delivery cost. Did you ever see that? Don't talk about your Amazon Prime account and all. Sir, I have Amazon Prime, so I don't have any deal. Forget about. But for Amazon Prime account also, you paid some money, right? That is going to here only. Fine. So delivery cost. So the delivery cost is equivalent to this ordering cost. So now here, what you have to understand is that you're ordering 12 soaps, you're ordering 50 soaps, you're ordering one soap. It doesn't matter. It doesn't, independent of a quantity. If you're ordering single time, the delivery cost is same, right? If the delivery executive is coming and delivering you one soap, 12 soaps, 50 soaps, it doesn't matter. Is going to cost you 30 rupees, isn't it? Let's say the delivery cost is 30 rupees. Yes or no? Yes. So now what I'm going to that is what is ordering cost, the delivery cost. So how many orders you are doing in a year? Let's say in a throughout year you have some. This is your Jan 1st, and this is your December 31st. Throughout year, monthly once you are trying to go to shop and bring the soap, or monthly once you are trying to order the soaps, or monthly yearly sometimes you ordered. So number of orders, how many times you ordered? One order, first order, second time order, third time order, fourth time order, fifth time order, sixth time order. Six orders into cost per each order. What is the cost per each order? 30 rupees, 30 rupees, 30 rupees, 30 rupees, like that, keep on. So add all of these costs, right? Or number of orders are 5, 6 orders into each cost is 30. So that is what is ordering cost. Okay. So what is the setup cost? I'll tell you, but not now. I'll tell you what is setup cost. Okay. Setup cost. Okay, I'll tell you here itself. Setup cost is nothing but bringing manufacturing facility. Ordering cost is when you are trying to bring in the finished goods. Right? And setup cost is that you have a manufacturing company. And you are trying to manufacture something, and then without buying it, you are using it. But you're not buying it, but you're manufacturing it. So there is some cost associated with that, isn't it? There is some cost associated with that manufacturing. So what is the cost? You have to set up machines, you have to set up manpower, all these things. Instead of buying, you are manufacturing yourself. So if you're ordering finished good, then ordering cost. If you're taking from a manufacturing plant that is owned by you, then it is called setup cost. Both are same, nothing but number of orders or number of setups into cost per order or cost per setup. Fine. Now, holding cost or carrying cost. It's very important. What is holding or carrying cost? What is that? Okay. If you see this figure here, I'll draw the same figure here. Okay. What is that? Let's say Q is here. Please remember the notations are very important here. Q is denoted by the quantity. Q is quantity, and T. This T is time. Q is quantity. T is time. Okay, fine. So let's say you bought some soaps today. Okay? You're buying soaps, some 12 soaps today. In the sense, this is 12, and this is today. Today, what is the date? Today is 16th March. 12 soaps you bought. Okay, and you opened one soap and you started using it. And on, let's say, on 20th of March, your quantity will be 10, and take some 25th of March, your quantity might be reducing to some more 7, then 6, like that. It will become 0, let's say by April 15th, let's say. So it means that as time is increasing, your usage is increasing, the quantity is reducing, right? So this is your maximum quantity, and you have minimum quantity. So after completing it, you're not going to buy it. Even the grocery store is near, it's okay, fine. Let's assume that the grocery store is very far, and you have to go one day before to get the groceries. Let's say you're not staying in India, you're staying somewhere in foreign, which is in foreign also. You're not staying in the cities, you're staying in the outskirts. Let's say it's very difficult to get a grocery stores around in foreign. You have to go little far. Let's say, okay. Now you're not going to buy new soaps on April 15th. You're going to buy before day only. Or else, let's say you're ordering, and you're not going to order on 15th April. You're going to order some one or 2 days before, based on the delivery. If you're going to order, you're going to order here, then only by the time you're reaching April 15th, your full order will be getting and refilled at this point. Again 12 soaps. Are you getting my point? This point you're understanding what I've made here. This point, yes, very important. You are going to order little before so that that delivery time will take. Okay, fine. Now here, let us assume that you have a cupboard and you bought a soap, and let us assume that this soap is having some peculiarity or some specific condition that you should not what you say, store this soap in general ambience. You have to put in some box. You have to put in some box so that humidity will not affect it. That is, if at all you are putting this soap outside to the general normal ambience, it might consume the humidity, and then the value of the what you say, the value of the soap might degrade. Let's say some Ayurvedic soap, maybe we are using it for some specific purpose. Let's say we have some skin condition and we are using that soap. So they say that you have to save that, you have to store that soap in a specific box, right? You don't have that box. Let's say you're going to rent it. Let's assume that you're going to rent it, and it means that initially you have to spend money for saving 12 soaps. As time is increasing, your soaps are reducing. You're taking one by one, so you have to save 10 soaps later on 20th of that. And again later on you have to save, you have to save only 8 soaps, and again you have to store some 6 soaps. As you're keeping on moving, your quantity is being reduced, your quantity of soaps are being reduced. In the sense, let us assume that there is another person who is having this box and saying that if you are saving one soap, I'll cost you 0.1 rupees, like that they're saying. So on the 16th of March, you have to pay 12 into 0.1. On 20th of March, you have to pay 10 into 0.1. Like that, you keep on going. This is 0.1 rupees per item per day. Let's say like that they're saying. Okay. So as what I'm trying to say here is nothing but, as the time is proceeding, the holding in the sense, the storing cost is reducing because the quantity is being reduced as the time is proceeding. That is the important point. I repeat, as the time is proceeding, the holding cost is reducing because quantity is being reduced. So, but we are not bothered about at an instant. We are going to bother for a simple one order. This is full one order. So instead of carrying instantaneous this thing, what we are going to calculate average inventory for the period. Why average? Because here our maximum we have minimum. Instead of that, we find some average quantity, some average, Q average. We're finding some Q average, right? So average inventory quantity into carrying cost per unit per time, 0.1 rupees per unit of soap for some time. This is very important. This is your carrying cost, okay, per unit per time. Okay, like that, shortage cost. There is another cost, shortage. What is shortage? Who will be in charge of holding the material? Obviously, that is what industrial engineer has to take care of it. He has to calculate all this. That industrial engineer has to take care of this purchase cost, ordering cost, holding cost, shortage cost. All the things have to be taken, and then that fellow has to optimize it and say, okay, I will buy so and so quantity of Q, so that the adding of all the cost is as much as minimal possible. That is the important thing that industrial engineer has to do. Okay, and there is one more cost called shortage. Sir, how, sir? Why? Sir? Shortage also will be having some cost because we don't have material itself. How is it going to cost you? You are not buying any. Shortage means, what is shortage? Let's say you have some mobile company, you have some mobile store with you. You are running a very nice mobile store in your locality. You have all kind of mobiles. Name it. You have all the mobiles with you. That one person will come and say, I want Samsung. You will give it. Some model iPhone. You will give it. OnePlus. You will give it. You name it. you are very famous there, let's say. Now, and you have to be in with the trend, right? You have to know the trend. Now, let's say the the days of OnePlus some 12 is in demand now. Let us assume that. Okay, so you have to know how many customers are going to come. So let's assume that you thought that okay, I'll order some 100 phones from the OnePlus company, so that I'll bring it to my mobile store and keep it. So person will come and do. So and you assume that this will go on for 1 month. So what happened? Within no time, within 15 days, you thought of selling this 100 mobiles in 1 month. But within 15 days, due to high demand, within 15 days, what happened? All the mobiles have been sold off. Sold off. Now, some other customer on 16th day, he'll go. He knows that your mobile store is very famous. He'll go. This fellow will come and ask, "Bhaiya, give me OnePlus store phone." You don't have it. How is going to cost you? One is whatever the profit. Let's say you're for one mobile, you're getting a profit of 3,000. Let's say 3,000 profit you're getting for selling one mobile. Let's assume. On 16th day, this fellow came and asked, "I want one mobile." Now you are unable to provide. Whatever the profit you are supposed to get, you are not getting it. Second, so you lost the profit. You lost the profit. That is shortage cost. Another thing is loss of goodwill. What is loss of goodwill? That fellow will lose good impression on your mobile store. Even though in that locality, everyone is saying that that mobile store is good, but as a personal experience, I am not satisfied because I didn't get what I wanted. So next time you won't go there. Even though some kind of mobile is available there, you don't go there because you feel that last time I went, I had a very bad experience. I don't want to go there. You lost the customer's goodwill. Okay, so that's why shortage or stock out also will incur some cost. Are you getting all the costs? Did you get all the costs? Important points here. Very good. Now what we have to do? We have to add all of this 1 plus 2 plus 3 plus 4. That is your total cost. So that is so everything has been discussed in detail. So number of units purchased into cost per unit. So cost per unit is written as C subscript small u. Okay, cost per each unit. This is unit cost. More or less you can say as unit cost. So purchase cost is equal to number of units purchased into CU. Same. Ordering or setup cost. Number of orders into cost per order is given as C subscript small o. C subscript small o. That is ordering cost per each order, CO. Or if you are setting it up manufacturing, then cost per setup also is CO. Okay, fine. And as I told you, carrying cost is average inventory for that period, because for one order, one period, into carrying cost per unit per time, and that is given as C subscript C. Okay, carrying cost per unit per time. Okay, then shortage cost is nothing but number of units short. How many units you are unable to provide to the customer on that certain period of time, or you can say average period of time, into shortage cost per unit per time again. This is also per time, because time is important. Sometimes you will say, sir, I'm very sorry, sir, we are unable to provide that phone today. Can you come day after tomorrow, so that I will give you 5% discount, sir, because you are luring the customer. 5% discount is loss for you only, but still you are trying to give, right? So shortage cost per time per unit, that is written as C subscript small s. Okay, so in a just I can say CU is unit cost, CO is cost per order, CC is carrying cost per unit per time. CS is shortage cost per unit per time. Okay, these are four important unit costs. Okay, now, so in inventory we have different types of inventories. One is nothing but transit or pipeline inventory. It's nothing but what is a transit of pipeline inventory? Okay, you ordered some laptop. You ordered some laptop in Amazon. Okay, and you ordered 12, you are ordering on 16 March, and the expected delivery is on April 10th. Let's say it won't take much time. Let's assume that it is taking April 10th, but cash on delivery system is not available. You have to pay money at that time only. So you have paid 1,50,000. The laptop is very costly. You paid 1 lakh because there is no when you are not paying in EMI also, you have cash, you are paying it 1,50,000. You paid 1,50,000 on 16th March and you don't have product, and process is going on. Correct? Process is going on. That fellow has to pack that, move from some place to here and there, some transportation company, that this, everything is happening. And that is also inventory. Sometimes something might happen there. So you say, sir, Amazon will take care of it. It means that there is loss for Amazon, no? So transit or pipeline inventory. It means that the inventory which is in transportation. That is what is transit or pipeline inventory. Fine. Now, buffer or safety stock, very important. First, we have to understand what is safety stock. Buffer, or you can call it as buffer stock, or also you can call it as safety stock as well. Okay, fine. So the very good example for buffer or safety stock is trekking. Let us assume that we all are going for trekking, or we are going for a tour, a very nice tour, and we planned that tour or trekking for 10 days. Okay, and we thought that okay, for each day I'm gonna wear one pair of trousers. Okay? So let's say we are all male people who are going for trekking, or maybe we are having some women accompanied, but let's assume that for a male we have a shirt and a pant, right? So we assume that for each day I'm going to wear one shirt and one pant, so that I'll keep on moving all the days happily. But are you going to take 10 shirts and 10 pants alone for your trek or for a tour? Or are you going to take less, or are you going to take more? How many? Are you going to take more or less? More. Why? Why are you going to take more? Hello? Yes. Any disturbance can happen, in the sense you're going for a tour. Suddenly you, for a sightseeing, you got down and you have happily enjoying it. Suddenly without any intimation, it got rained. Or maybe you fell down and some dust has, some wet dust has stuck to your pant or maybe shirt. So you immediately have to change the dress. It means that you need extra pair, right? So you take some extra pairs. Like that, you take some extra pair, that is two. Two I'm taking extra. But that is, you're expecting that something might happen. Let's say you did, nothing has happened, but still you have to carry that extra two in your bag every time, isn't it? Yes or no? Every time, whether you're using it or not, you have to keep on carrying it. So it means that the carrying cost is added to the safety stock, even though you're using it, but you have to carry because you don't know anything can happen. So that is what is safety stock. That is what is safety stock. You will not use that extra stock or safety stock until unless it is required. So that is the reason why, if you see the definition here, it is minimum amount of inventory kept throughout the year and is used only during adverse conditions to prevent stock out. Stock out. So if you're coming to a mobile store example, some person is coming and asking for the mobile. You don't know him. You'll say, sir, can you come tomorrow or day after tomorrow? If some regular customer is coming, you know that fellow very well. Maybe he's your relative or maybe he's a very regular customer to you. Then you don't want to lose that fellow's goodwill. So what you do, you have some 20 mobiles hidden in some other place. So what do you say that, sir, wait for 1 hour, I'm bringing it. That is what is safety stock. You will use only in adverse conditions, right? So it is held for protection against the fluctuation in demand during the lead time. Lead time. Now comes lead time. What is this lead time? Okay. Okay, fine. So let's assume that we are ordering something. I told you already, as this is getting consumed, we have to order little more before. We have to order little more before, so that by the time this thing is coming zero, the shipment that will come on this day, so it will refill, isn't it? Yes or no? Yes or no? Yes. Fine. Now lead time is nothing but the time of placing an order. You are placing an order on so and so date. Let's say this is on 5th August 21, and you are receiving your order on 18th August, that is 21. So this is what is lead time. Let's say you're ordering today 16th March. Let's assume that you're ordering 16th March and you're getting on 20th March, let's say. So what is the lead time? Lead time is 5 days, isn't it? 5 days. Yes. So that is the time gap between lead time and if there is any fluctuation during this lead time, then only you will use this buffer or safety stock, because this is the time in which you don't your thing is fixed on this time, because you assume that you have more quantity here, but the time as you are getting consumed, less amount of quantity is left. You, if some kind of fluctuation is happening during this time, so this fluctuation is very very dangerous. That's the reason why you use buffer stock in this kind of time, that is lead time. Okay. Yes. Fine. So that is how you are carrying this safety stock with you, so that you don't get the stock out condition. Even though you're getting stock out condition, safety stock will be used accordingly, right? So that is the definition for safety stock, and that is the definition for lead time. Hope you are understanding the concepts, right? Okay. Next is nothing but some seasonal inventory. Seasonal inventory is nothing but you umbrella, raincoat, all these things are some inventories which you have to increase during, now summer is coming, right? So we are most probably will be taking more cool drinks or maybe ice creams and all. So the vendors around you in the grocery store or maybe somewhere else, so more and more cool drinks or ice creams or some kind of cooling items are available, right? Right. And during winter season, umbrellas and raincoats are having more demand. So based on that, you keep on changing the inventory, because if summer is coming, there is a shop. There is a shop near you. If summer is coming, so obviously he has a big fridge there. So obviously there are some cool drinks inside that. So more number of people will come. It means that he has to keep more amount of inventory in that. That is what is seasonal inventory, right? And anticipation inventory. This is very important. So you don't know what is going to happen in future. So that cannot be anticipated. So there is no certain this thing. Let's say today, assume that Russia and Ukraine are not fighting. Let's assume that. So we didn't know that. So suddenly today night, I mean, they're fighting. Let's say they're fighting. We know that we all know that they're fighting each other. So today you're sitting happily and you're eating your dinner. Suddenly in a TV you got saying that from tomorrow the petrol price is increasing from 100 plus some 20. Let's say the petrol price is 120 rupees per liter. They're saying per liter 20 rupees increase is very dangerous. Well, like maybe it is increasing 30 rupees. Let's say. So then what do? Immediately after having dinner, you go and you go to a petrol bunk, and a very big queue will be there. You go there and then you take full tank. Make it full tank. Why? Because today is the last day. You are getting it for 100 rupees. From tomorrow, you are getting it for 130 rupees. So you don't know anything can happen because government policy change, price hike, there is some strike going on, there is some shutdown, some war is going on, anything can happen. Or big sale is going on, Amazon big sale, full discount they are giving. You're buying even though you are not, you don't want now, you buy it, right? So these are all known as anticipatory or anticipation inventory. Fine. Now there are two more classifications of inventory, that is direct inventory and indirect inventory. What is direct inventory? Direct inventory is nothing but, first we have to know what is dependent and independent inventories. What is dependent? Independent car. So if you're a car manufacturer, you're working in some Maruti company and you're manufacturing some cars. Car is independent of anything. So some let's say in 2022 you're expecting some 500 cars of certain model. We assume you thought that okay, 500 cars I need, so that 500 customers will come and ask me. You thought, you did some forecasting and did that. So, and these cars are independent of anything. But if you are buying, if you want to manufacture car, they have wheels, they have tires. So these two are dependent. So if you are doing 500, so based on that you have to bring certain amount of into 2000 wheels, some buffer, some 200 wheels. Based on that, so many tires you have to bring. So that is what is dependent and independent inventories. Direct are nothing but which are integral part of your manufacturing. That is your raw material, purchase, finished goods. All these things are direct inventories. Indirect, direct in the sense all this raw material is going into car, right? All the raw materials that you're going to buy are maybe wheels, all the tires are raw materials. It's going into the car. You can see, you can physically feel that in the car. But indirect inventories are nothing but oil. Some oil you are using and cleaning it. It is not visible in car, but it is required. Some lubricants you use for manufacturing, you are not using. It's not visible in the car. It's not. They are not tangible, right? Petrol, some material you used, office material you use some clerk to make all these entries, and you paid some money to the clerk. That those and all are not visible to the in the car, right? How clerker thinks that okay, you bought some 4 or 5 bundles of A4 sheet pages things and kept so that you can use it for printing. That is also cost. That is also inventory. Why 4 5 bundles? I can buy 10 bundles. I can buy 200 bundles. Why only 4? That also is a quantity queue, right? So those are all indirect inventories which are not visible, which are not what you say integral part of the final product. Fine. Now there are two systems in inventory. What is the system? One is queue system. Second is P system. Okay. One minute. Okay. One is queue system. Another is P system. What is queue system? Queue system is nothing but fixed order system. P system is fixed period system. Order, quantity, queue. How many you are ordering? Period, time T. How many you are ordering per time? If T is fixed, something is happening. If Q is fixed, something is happening. We'll see what is that. First, we have to know a diagram. Already, I told you clearly. If at all we are trying to plot these things in a XY plot, this is Q, that is quantity. This is T, that is time. And inventory is full. As your time is proceeding, inventory is completed. Right? And I told you already, this is the point at which you are trying to order, and this is the point at which you are receiving it. So what is the distance between that two? What is the distance between these two? Anyone? It is lead time, right? So at this point, if you are checking some quantity, at this time, if you are checking the quantity, this is the quantity that is left. This is the quantity that is left. So this is the quantity that is left. Some quantity which is left in the garage. You have seen, let's say you're ordering 12 soaps, and at certain point of time when you're ordering, you saw the garage and some 2 soaps only are left. And this 2 quantity, this q left is equal to 2. This 2 is known as reorder level. Reorder level. The level at which the quantity of order, the quantity level at which you're ordering again is known as reorder level. Either you can look into quantity and order, or you can look at time and order. You have two systems. Let's say we have some rice in generally, let's say we are rice eating people, let's assume that, and we are eating rice, or maybe we are eating roti, wheat, let's say. So what you do, you brought some 20 kgs bag of rice or wheat, let's assume. One, you look at the bag and see, okay, some 2 kgs are left. Then now this is the time I have to order. Sometimes you will see at the quantity. Sometimes you see it's been 1 month I've ordered, and let me order again. So you are seeing time here sometimes. So if you are seeing quantity and ordering, then it is called reorder level system. If you are seeing time and ordering, then it is known as fixed period system. For fixed period, you are trying to order some quantity, variable quantity. So for that, I will show you two different graphs. Or these are the graphs. You see, in 1 year, let's say this is full 1 year. Here and here is 1 year. Let's assume that it's 1 year. In 1 year, you're ordering fixed quantity. I don't know. I'll go to shop. I'll take 12 soaps. Maybe I'll take some fixed quantity. Maybe I'll take 20 kgs, 25 kgs of rice, 25 kgs of wheat, whatever it is. Then I'll use it accordingly. Again, after some time, this time, some 2 months are over. Then I went to shop. Again, 20 kgs only I've ordered. And this time what happened, I was not in home, I went to somewhere else for taking trip and all. It took longer time to consume that. Maybe some 6 months it took, or maybe some 8 months it took. Next time I went to trip and tour, I brought some other relatives to my home. Now again I ordered 20 only, but those are consumed very fast because you have some relatives in your home. It has been consumed very fast. So it means that what I'm saying, that every time I go and I'll order same quantity, fixed order, in different interval of times. Okay. In other system, I don't care about quantity I'm ordering. I'll care about time. I'll just go every 3 months, every 4 months once I'll go. Okay, 4 months. I'll go January, April, May, then some, around October ending I'll go. Every time I go, but based on situation, I'll order. You see that, okay, this month I'll use, okay, fine. This time already I'm left with some more things. So let me do one thing. Let me order a little less because I'm not in home. Then I will use it for 4 months. Next time I'll go and I'll order because this time my relatives are coming. I'll order a little more, and then those will be consumed on 4 months. So this is what, no matter the quantity that you're ordering, you're going to fix the time. That is the difference between these two, fixed order and fixed period. Is it clear, guys? Yes or no? Okay, fine. Now we are going to discuss about important, from here only the syllabus is getting started. All the things that we have discussed in the previous slides for this 1 hour is nothing but the important rudiments, the basics of your basics for your inventory controls. Some terminology introduction and some different classifications, categorizations, and all these things, different costs, all these things we have discussed. Now the inventory models are categorized into 2 models. The first one is your deterministic inventory model, and second one is your probabilistic inventory models. So what is the difference between probabilistic and deterministic? Deterministic is an ideal one. It doesn't happen in real life. It's a simple ideal. But why do you care with ideal? Why do you want to even dare to do ideal things? Because you want to simplify things and do some calculations, and then you can extend it to the real life situations. That is what we do, right? This is what is a probabilistic real life situations. Fine. In deterministic, what is deterministic? Determined. I am determined. I am fixed with something. What is that? Okay. So in this model, demand rate and lead time are fixed. If you are saying it's a deterministic model, demand rate and lead time are fixed. in the sense, you know, this is smart is my demand rate. So now what I'm saying is that if this is time t and if this is q quantity, the rate at which we are consuming at some rate, no, the slope it is consuming negative, right? This is negative, this is positive slope, and this is negative slope, right? So the rate at which consuming negative slope, so it is consuming, it finished, it is reducing, right? The rate at which we are consuming q by t is demand rate or consumption rate. D is given as consumption rate, the rate at which we are consuming, consumption, or demand rate at which demand is coming to your shop, consumption or demand rate. Okay, so that is a slope. So you know the demand rate. It means that you know that for next 2 months, 100 customers are only coming. 100 only I have to bring. 100 only is going to be sold out. Not one more, not one less. And also lead time is fixed. What is lead time fixed? Lead time is fixed means I don't know. I am ordering today. I don't know how within 5 days it is going to come. Lead time is 5 days. Anything can happen. You don't know. Hey, we don't know, right? Like suddenly some road accident might happen, and whatever the delivery that has to come to you, it didn't come. Or maybe sometimes some lockdowns are going, some some fight war is going on, something has happened, some due to some technical reasons or non-technical reasons, something happened and the order hasn't delivered to you on time. But in deterministic models, those are not considered. What is the only thing is that it is fixed. Lead time is fixed. 5 days means 5 days. It has to come. It will come. Right. So that is what is important. So demand rate and lead times are fixed. That is known as deterministic models. If lead time is fixed, means right time, right quantity is coming. Demand rate, already. I told you already. 100 mobiles has to be sold in 1 month. I told. So real life situations, it because of the high demand, 15 days only happen. But in deterministic models, 1 month only will take. If 1 month only will take, no need to carry any safety stock, right? No need to carry any safety stock. In the sense, like if you're going for trekking, I told you already 10 days. So we are assuming that I need only 10 pairs. There is no problem, no rain, nothing, everything is on smoothly, it is going. So no need to carry extra pair. Safety stock is not carried. So as demand rate and lead time are fixed, there is no need not to carry safety stock. So that's the reason why these models are known as deterministic. What are they determined? Deterministic. Some people will say you are very determined. What is that very determined? Determined means you are fixed on something. I am determined to do that. What are you determined to do that? Because you are fixed. No matter what, I'll do that. It might happen, it might not happen. That is different, right? Next, probabilistic. This is real life situations where this demand rate can change, lead time can also change, and that is the reason why we need to carry safety stock. We need to carry safety stock to prevent stock out, during adverse situations, right? So you see, this was supposed to be like this. If you are extending it, it should be like this, but it got finished before only, because from here the demand, let's say this is demand D, but the demand at this thing was little faster. The slope here is, let's say, some D dash. Obviously D dash is more than D. The slope is complete. You expected this to happen, but what happened? Instead of that, you expected this to happen, right? But instead of that, this has happened. So this is the place at which your out of stock is happening, and that is where you have that buffer stock will come into picture. Buffer stock in the sense the safety stock that you have kept in your garage or maybe in your store, so that you'll be using it for some important situations, right? So in a nutshell, what I can say is that important points: demand rate and lead time are fixed. No need to carry safety stock means deterministic. Demand rate and lead time are not fixed. Any uncertainty can happen, and you have to carry safety stock is known as probabilistic. That's it. That is the difference between probabilistic and deterministic. And I also told you that in your syllabus, if you see that in syllabus they didn't mention probabilistic, they mentioned as safety stock models. They mentioned that as safety stock models. That is the reason why they have mentioned probabilistic as safety stock, because you have to carry safety stock. If you go back and see the syllabus, that is what has been mentioned. What is that? Safety stock models. Why? Because you have to carry safety stock in probabilistic situations, uncertain situations, right? So, fine. Now, yeah. Now let's have some notations. Already some of the notations are clear to you, but yet again we'll introduce some system here so that we'll follow the system throughout the classes. Okay, fine. So already I told you D is demand rate or consumption rate. That is nothing but annual. So please remember, every time we are considering for 1 year, 1 year, 1 year, 1 year, 1 year. Very important. Until unless something is mentioned, you have to consider it as 1 year only. Okay, annual or yearly demand of inventory, that is units per year, quantity per time, units per year, quantity per time. Okay, that is D. Next is quantity Q. Already you know how much has to be ordered. Inventory at each order point. Order point means today, maybe after 1 month, maybe after some other point. How many quantity are ordered, and that will go into inventory. So this is your quantity that you have to order. That is what you have to find. How much Q you have to find. We are trying to do all these things so that what is the quantity that we have to order on so and so date, so that our cost is minimized. Which cost? Purchase cost plus carrying cost plus ordering cost plus shortage cost, all have to be minimized, right? So now, number of orders in a year. How many orders you are going to pay in a year? It's nothing but D. It's given by D by Q. Sir, why is that D by Q? See, D is nothing but units per year. Here we have seen already. D is nothing but units per year. D is units per year, right? By Q. Q is what? Q is for units per order. How many units you are ordering per order? So units per order, right? Units got cancelled. 1 by year by 1 by order. So order will go on to top. Order per year will be order per year. So that is what I have written here. Order per year. In the sense, how many orders in a single year? That is number of orders in a year. Okay. Next, time. Time is nothing given by 1 by number of orders. Why, sir? 1 by order per year will be year per order. In the sense, in a single year, by orders will give you time gap between each orders. Time gap in 1 year. Let's say this is 1 year. 1 year divided by, you're ordering some 5 times, or maybe you're ordering some 6 times, let's say. So 1 year can be written as 12 months as well, right? 12 months. In a sense, 6 by 12 by 6, it means that 2 months. So once in 2 months you're ordering. Time gap between two orders is 2 months. So that is why it is 1 by n. 1 by n. Right? N is D by Q, D is 1 by n, or you can write Q by D also. Right? And already clearly mentioned that CU is unit cost per order, cost per order, carrying cost per order, carrying cost per unit per time, shortage cost per unit per time. What is the time? Time is nothing but for one complete year here, one complete year per year. Okay. Hope you are understanding all these things. Okay. Fine. Sorry. Now I told you we are discussing deterministic models and probabilistic models. Now we are going to discuss the first model, that is the first model. There are 4 models. Okay. There are 4 models in deterministic models, and there are 2 models in probabilistic. So total 4 plus 2, 6. We are going to discuss 6 models in inventory control. Okay. First model in deterministic model is economic order quantity model, or Wilson-Harris model, or infinite rate of replenishment model. Okay. So for that, if you see the graph here, what is that? Clearly everything has been mentioned. Already we have seen that Q is the quantity, that is the maximum inventory level. Maximum inventory level means maximum level of inventory. Inventory in the sense maximum quantity that you are trying to order, so that you can use it in later stages, right? So that is called quantity Q. You ordered, happily it is, you ordered this much quantity is filled, slowly using throughout this time. And what is the using quantity per time is given as slope D, and this D is fixed. Why it is fixed? Why it is fixed? Because it is a deterministic model, right? And then you are having some lead time. This is the placement of order. This is the receivement of order, right? And at placement order, you are seeing some quantity which is left in the garage. That is what is your reorder level. You have already seen that, right? And like that, we can keep on making the same cycle repeated again and again, repeated again and again. This cycle, same cycle is repeated again and again. Okay, and we have drawn the reorder level for all the orders. And certain, let's say if you want to know what is the quantity left at certain time, you take some point at certain time t, then you can see, and this is the quantity that is left. So this is the quantity that is left at certain time t. Okay, so if you say this d can be written as q by t, right? That's what they have written, and it can be d can be also written as q. This is the quantity qx. This is qx by tx, right? By tx, right? And also you can write reorder level divided by lead time also as d, right? So that's the reason why what I've written d is equal to q by t, qx by tx, reorder level by lead time. Very important equation that you have to remember. Is it clear, guys? Yes or no? Hello? Yeah, good. Now, so if you see, I was already mentioning that we have to minimize that cost, minimize that cost, minimize that cost. I've been telling from long time, right? Now the time has come. So the cost, total annual cost is given as TAC, or you can write instead of total annual. Why? Because we are considering everything per year. No, we have already mentioned in this thing year, everything is year, right? So that's the reason why we are considering per year. Instead of writing total annual cost, you can write as total cost. You are dropping that annual. That's it. So total annual cost is nothing but purchase cost plus ordering cost plus carrying cost plus shortage cost is there. But in this economic order quantity model or Winsor Harris model, shortage is not allowed. Shortage is not allowed. Shortage is not there. Simple model shortage, we are saying that there is no shortage. We are assuming that. That's the reason why shortage cost is not added in this thing. But we'll add in the future things. But as of now, for simplicity, we are assuming that there is no shortage. So hence total annual cost is nothing but purchase cost plus ordering cost plus carrying cost. We know that already, right? So now individually you have to see what is each cost. We have already seen that purchase cost is nothing but number of units purchased into unit cost, right? Number of soaps 12 into 50 rupees. We have seen that, right? So that is direct cost, fixed. Why it is fixed? Why it is fixed? Because let's say if you're ordering 100 soaps, the CU is not going to change, right? It might change when some discount is given, but we are not discussing about any discount here. Let's say there is no discount, no matter how many quantity you are purchasing, there is no discount. So this purchase cost is fixed. You're ordering 100, you're ordering 200, you're ordering 1000, 10,000. Also this unit cost per each soap is rupees 50 only. It is not changing itself. So it's fixed one, right? Now ordering cost is nothing but number of orders into cost or order cost per each order. Number of orders you are making in 1 year, right? Number of orders you are making in 1 year. Let's say if you are in 1 year, you're making some 50 orders. 50 orders you are making in 1 year, right? 50. Let's say each ordering cost is 30 rupees. This is how much? 1500 rupees you are spending for 1 year, right? Sometimes in another scenario, you ordered only some 10 times. You ordered only 10 times in a year. So 10 times. So if you're ordering 50 times, the quantity that you're ordering will be less. The quantity you are ordering will be less quantity, because 50 times you're ordering, no need to order more, because you know demand for 1 year is fixed. You know that already, right? And if you're ordering only 10 times, your quantity that you have to order will be little more, right? This is your 10 times your order. 10 times into 30 will be 300 rupees. That's it, right? So one problem here, if you're ordering less, and you have to order more number of times. More number of times, you are spending more money for your ordering. If you're ordering quantity more, your quantity is more, but you're ordering less times, in the sense you are reducing your ordering cost. That's okay. That's okay. But if you're ordering more quantity has to be kept in the garage. More quantity has to be kept in the garage. More quantity have to be kept in the garage, right? So your carrying cost will go up. In the second case, carrying cost will go up because more quantity is there. The person will charge you more. Less quantity is there. The person will charge you less. So what is happening here? This this ordering cost and carrying cost are having some kind of inverse relationship. In the sense, if ordering cost is if number of orders are increasing, carrying cost will come down because quantity is reducing. If ordering cost is coming down, in the sense you are having more quantity to be ordered, carrying cost will go up. So we have to get stuck between with these two. But anyways, let's not discuss that. I'll discuss that in the form of a graph. So number of orders is given by n. Number of orders is given by n into CO. Number of orders is given by n. And in the previous slide, we have seen that number of orders is given as d by q. In the previous slide, we have seen that number of orders are given by d by q. So here we can write as d by q into C naught as well, right? Now next is carrying cost. Carrying cost is average inventory into CC. Average inventory I can write as q by 2 into CC. Forget about all these things, but average inventory is q by 2 into CC. So now what we have to understand is that PC is nothing but number of units purchased into CU. OC is nothing but number of orders into C naught or D by Q into C naught. Carrying cost is Q by 2 into CC. That is average inventory into CC. Okay, fine. Now we have to add all of these things. So purchase cost plus ordering cost plus carrying cost, that is PC constant. It's not depending upon the quantities that you're buying. It's not going to change anyways. So that's the reason why we are making this as constant. And number of orders into order per each cost per each order. Average inventory into carrying cost per unit per time. And if at all you see, this is your constant, and if you see, this is what is your inventory cost. This purchase is not coming as an inventory cost because it is constant. It is only calculated per annum. And if you see the other part which is there, that is your ordering cost and carrying cost, is given as inventory cost, total inventory cost, TAC. So if I can write like this, that is total annual cost is equal to purchase cost plus total inventory cost. I can write like this. Total inventory cost is nothing but ordering cost plus carrying cost or holding cost, you can also say. Okay, fine. Now, so total inventory cost is ordering cost plus carrying cost. Hence it is D by Q into C naught plus Q by 2 into CC, C naught, CC, right? And also I have written total annual cost is equal to purchase cost plus total inventory cost. Fine. Now what is that? What is that happening? So what is Q star? Let's assume that Q star is the quantity that we are going to order for each single order. In each single order, that is the quantity that we are going to order. Okay. So what is the quantity that we are going to order to minimize the total inventory cost is Q star. So why it is Q? Well, that is what we are trying to find. So if you see in this equation, Q, those are variables actually, variables. And D is fixed, deterministic model, D is fixed. C not fixed. We are not changing delivery cost. You can't say that like you are ordering 100 items, you are ordering one item, it doesn't matter. 30 rupees, I will take 30 rupees. One time I am coming, 30 rupees. Carrying cost, I'm giving 100 items, I'm giving one item, two items, doesn't matter. Item per unit per time, I'm taking so and so cost, fixed. So D naught is fixed, C naught is fixed, and CC is fixed. Only Q is variable. Only Q is variable. So we have to optimize the Q. So if some total inventory cost is a function of Q, so that is what D by Q into C naught plus Q by 2 into CC. So you are differentiating that with it is 0, you are doing some equations and all, and you are finding that optimum quantity, that is economic order quantity, that is under root 2D C naught by CC. Under root 2D C naught by CC, very important equation. Very important equation, this equation. This equation is very important. Under root 2D C naught by Cc. This is a simple Wilson-Harris model without shortage. Please write this formula in your formula book and try to remember as I try to memorize this and revise this as many times as possible. It's known as economic order quantity. It's known as economic order quantity or optimum quantity to be ordered at each order point so that your total inventory cost is minimized or total annual cost is minimized because purchase cost is constant there. Is it clear, guys? Yes. Yes. Fine. Fine. Now, next. So you got the quantity. You got the quantity Q star. This is your EOQ, optimum quantity that you have. Optimum quantity in the sense like the quantity that you have to order each time Q star, and that Q star is repeated again and again. If you're ordering this much quantity at each order point, at this time, at this point, each order point is nothing but this one, ordering point. So it means that now you have to calculate the total cost also. How much is the total? So the total inventory cost is nothing but you have to substitute this Q star back into this equation, right? Back into that equation. If you are substituting that, you are getting this value, that is under root 2D C naught Cc. This is your minimum total inventory cost or optimum total inventory cost. You have minimized it. You can't go below this. Optimum TIC. Clear, guys? Please write this formula as well. That is TIC is equal to under root 2D C naught Cc. Fine. Let's proceed. Okay, this is a very important graph that we have to discuss. That is, you see, we have so many times have drawn this time and quantity. Instead of that, what we are doing is we're drawing the graph between cost and quantity, order size, quantity Q. Okay, so let's see some things. One is your ordering cost. Ordering cost is inversely proportional to the quantity. I told you why. Because if you're ordering more quantity, it means that you have to order more times. If you're ordering if you're ordering less quantity, in the sense ordering cost is more. Means small amount of quantities you're ordering so many times. It means that for every time you're ordering, you have to pay some delivery cost or ordering cost. That's the reason why ordering cost is going up. If at all your ordering cost is, if your quantity that you're ordering in each order is more quantity you're ordering, in the sense one time only you're ordering big amount and you're reducing the number of orders are reduced, so ordering cost is less. Right? That's the reason why ordering cost is inversely proportional to Q. In the sense, it's simply inverse relation. Y is inversely proportional to X. I can say xy is equal to some constant like that. So this is a rectangular hyperbola. I can draw like this, right? This is X and Y, right? That's the reason why if you see the line, this line is your ordering cost line, right? And if you see the carrying cost is directly proportional to Q. So simple Y is equal to X. So the carrying cost line is simply like this, straight line. Quantity is increasing, carrying cost also is increasing. And if you add them, both of them, and draw the line, then this will be the total inventory cost. And for total inventory cost, you add some extra purchase cost, then it will become total annual cost. Okay. And if you see in this both the curves, this is the So this is the minimum point. That you want to minimize the cost. No, you want to minimize the cost. This is where the minimum is occurring. Totally. So that corresponding quantity Q is your EOQ. And if you see, one more important point is that at EOQ, your ordering cost curve and carrying cost curve are meeting In the sense, your ordering cost will be equal to carrying cost at EOQ. Your ordering cost is equal to carrying cost at EOQ. Is it clear, guys? Yes or no? Very good. Next. So this model sensitivity and all, let's not discuss. Yeah, the important thing is this. Yeah. Sometimes carrying cost will be represented as percentage of CU. In the sense, they won't explicitly say that I'll take rupees 0.001 per one per unit per year. They won't say like that. They'll say that I'll take some percentage of unit cost. If unit cost is, let's say, some 30 rupees, I'll take some 2% of unit cost, they'll say. So this 2% is I. I is percentage of unit cost. Okay, so we'll see all these things when we're discussing some problems. In the sense, like, let's say if your unit cost for one item is 50 rupees, they say that I will take 1.5% per month. So convert that into year, because everything is per year. So 1.5 into 12 will give you 18% per year. So it means that I'm taking 18% per year. So 18% of CU 50 rupees is 9 rupees per unit per year. So if I want to save certain item in my garage, I will cost you rupees 9 for 1 unit for 1 year. That is what is the meaning of this thing. Okay, fine. Now this is a simple example this thing. Let us solve. Try to solve this problem. Anyone who can solve this problem? I'll tell you the question. You should tell me the answer if possible. Right? What is that? This is in gate question, but just try to solve here and there. We'll see what is the answer. Anyways, so what they're saying, that the annual demand of valves per year in a company. What is this 10,000? What is this? What is that given? Demand in the sense what? Per year they're saying. What is that? What is that? Is it, yeah, it is D, right? D, yes, D is equal to 10,000. 10,000 per. Good. Next, the current order quantity per order. What is that? Q. Q, no? Q, no? Q, right? Current quantity per order is 400. The holding cost. What is this? Holding cost of valve is rupees 24 per valve per year. What is that? What is 24 here? Is it not carrying cost? Is it CC? Right? Is it CC? It is 24 per valve per year. Right? And the ordering cost is rupees 400 per order. So what is that? What is that 400? CO. Rupees 400 per, sorry, per order, not a year, per order. Good. Now, if the current order quantity, what is that? If the current order quantity is 400, is changed to economic order quantity. In the sense, I want to find out Q star. In the sense, like initially they are ordering 400, now they have changed it to economic order quantity. This is the first case, and this is the second case. Then the saving in total cost of inventory. Obviously, you know that if you're ordering economic order quantity, your total cost will come down. So if you're ordering this quantity, there is some cost associated with this cost one. And if you're ordering economic order quantity, obviously you will get some cost 2. Obviously, cost 2 will be less than cost 1. So what is that? What they're saying is that what is the saving? In the sense, cost 1 minus cost 2. That is what is your saving. Right? So they're asking this answer, saving. Can you do this? First, we have to find economic order quantity. In the sense, you have to find Q star, or that is equal to EOQ. Can you find what is the formula? What is the formula? Under 2D C naught CC. Tell me what is EOQ. Tell me what is EOQ. Substitute these values. What is that? That is 2 into 10,000. 10,000 into C naught is 400 divided by CC is 24. If you substitute, you get some value, right? And that you get Q star. And you want to substitute that into, you want to find out cost. The cost is nothing but under root 2D C naught CC. Find the cost. Right? So you got cost 2. So I want to find cost 1. How do I find the cost 1? Fine. Cost one is nothing but total inventory cost, that is D by Q into C naught plus Q by 2 into CC. This Q we have to substitute as 400, right? So let me show the solution, then you'll understand. See, this is the solution. The solution. It means we are having D, C naught, we are finding economic order quantity, and then total saving is TAC of Q minus TAC of Q star, cost 1 minus cost 2. And you can find TIC as this one, and Q star you got as this one. Substitute TIC of 400 minus TIC of 550 is 577. You are saving 944 rupees if you are ordering economic order quantity rather than 400. What is economic order quantity? If you are ordering 577 quantity per each order point, instead of 400, sorry, instead of 400 valves, you are ordering 577 valves at each order point. Then you are saving 944 rupees per year. That is what is the question is. Clear? Is it clear? Okay. Fine. Now let's go a little deeper. This kind of questions might not be asked in HL because it's very tedious to do that, but you have to know the concept. So I'll explain the concept, and then some conceptual questions are coming in the examination, then you should be able to solve them. Fine. Initially, what we have seen, we told that the CU or the purchase cost. The purchase cost is constant, I told you, or fixed, I told you. Why? Because the CU is fixed. If you're ordering one soap or if you're ordering 10,000 soaps, it doesn't matter. The CU is fixed, I told, in the economic order quantity. But in real life situations, that is not true. Slowly we are increasing the complexity here. The first model is very simple, very simple. Now we are increasing the complexity. We are saying that we are just adding one more complexity, that is that I have some discount. Here, if you are buying from 1 to 50 items, my each item is rupees 100. If I'm buying some quantity between 51 to 100, my cost will be 89 rupees for each item. And if I'm buying from 101 to 200, my cost per each item is 85 rupees. In the sense, you are getting a discount of 11 rupees here, discount of 150 rupees here in the case, right? So in this kind of scenario, what is the order quantity Q that I have to order at each order point so that my total cost is minimized, including this discount. Okay, what is in optimum quantity Q? That is what is the question for every model. Okay, so it seems that there is a price break here. I'll tell you what is that. So what you have done, you have some minimum quantity. As you're keeping on ordering, the cost is coming down, and again it is increasing because we have already seen in the previous gap because of this and this. This is your curve. This is your total cost curve, isn't it? Total cost curve, and that is what I've drawn here. This is your minimum cost at certain order quantity. Sorry, at a certain order quantity. Okay. So at 50, what happened? Suddenly there is a change in price. That's the reason why the cost has come down. Cost has fallen down. Because till 50, just calculate 50 into 100 is equal to 5,000. Now 51 into 89. Just buy extra one more. What is 51 into 89? How much is that? Tell me. 51 into 89. How much is that? Anyone? Please do the calculation. Tell me what is 51 into 89? Anyone? Calculator, come on. 51 into 89. It is 4539. See, is it reduced or not? This is 5,000. This is 500 has reduced. This is 5,000 here. And this has some 4539. Right? So that's the reason why it has dropped. And 52 into 89, 53 into 89, 54 into 89, 89 until 100 into 89, you're getting. What is 100 into 89? Some 8,900 you'll get. And if you're still reducing it, if you're buying 101, so just calculate 100 into 89 and 101 into 85. Obviously, this is 8900. 101 into 85 is how much? 101 into 85 is how much? 85 into 101. It is some 8585. So obviously, again the price will drop. Again the price. This is 8,900 and this is 8585. Again price has dropped. And again, as you're keeping on buying, the purchase cost will be the cost. So in the previous case, in total cost, we have written purchase cost plus ordering cost plus carrying cost, and we thought this is fixed, and then we are saying this is total inventory cost. So we have maximized this and we did the answer. But in this situation, we are not neglecting that, because purchase cost is also variable, because based on the quantity that you're ordering, your unit cost is changing. So purchase cost is also variable now. Purchase cost is variable, ordering cost is variable, and also carrying cost also is variable. This is your total cost. So now there's a technique that we're going to use. What is that? First we compute the feasible EOQ, then calculate the EOQ, total cost of EOQ, and then if it is higher, then you go to next price break and see that. So that is what we're going to do. So I'm telling you all these things as a fly. I'm not going to discuss that. So this is the question that is there. That means that from 1 to 999 rupees, 200 to 220 rupees, 1000 to 1499, 200 rupees. If you're buying 1500 to 1999, then it is 190 rupees. Then 2000 above, you're getting it for 185 rupees per each item. So first, what I'll do, I will be very greedy, right? Obviously, I want to go for a minimum price. So what I'll do, I will buy the this thing. I want to see at this unit price. I want to see the EOQ. So for unit CU is equal to this much, I will calculate the EOQ. Then EOQ is 1247. I got. As it is 1247 and 1247 is not lying in this range. So it means that this 185 is not feasible for this kind of quantity, because your 1247 is the optimum quantity that you have to buy. Then but it's not feasible because you have to buy 2000. So like that, I'll go and calculate for 190. I'll take CU as 190. I'll take CU as 190, and again I'll find EOQ. Then again I got 1231 as units. Again 190, 1231 I'm getting. 1231 is not in this range. So again I'm going and calculating for 200. For 200 unit cost I'm getting. If I'm calculating, if you are taking CU as 200 and then calculating EOQ, and then I got how much? 1200. 1200. Obviously 1200 is in this range. So it means that this is feasible solution. So 1200 is feasible in this range. But as you see, at 1500 and 2000, there might be a reduction in prices, because 1220 quantity you're ordering, it's okay, fine. But there might be chances that at 1500 or at 2000, this is the point at which the price is breaking, right? So I'll just calculate cost at 1200. I got cost at 1200 as 16 lakh 24,000, right? And at price break is 1500. I calculated price break at this thing. I'm getting 15 lakh. And another price break at 2000. I calculated. I got as around 15 lakh 5,000. Here at 15 lakh 43,000. So the minimum cost is occurring at 2,000 quantity. So EOQ is 2,000. So this is a simple procedure. Anyways, don't worry about this procedure, but you have to understand the price breaking is happening at so and so quantity, right? Please try to understand that. So this is another model with price breaks. Okay, this is the graph for that. See, the price break is happening here. So initially we have seen for this thing at 1200, you got the 16 lakh price. Then it increased till some value. Then again it fell down at 1500 because of price break. Again it went up. Again it fell down at 2000, and the minimum cost is occurring in so and so place. The minimum cost will correspond to the economic order quantity. That is what we have found out in the problem. And actually this problem is a previous year engineering service examination, but yet this is how we have to calculate. Even in GATE also this kind of questions have been asked. So this is the question that has been asked in GATE with these three price breaks: 749, 750 to 1499, 1500 to NO. The same procedure have to be followed, and we got this as an answer. Let's not discuss that now. And the third model that we're going to discuss in the deterministic models are nothing but production model or build-up model. Okay. Here some good derivations are going up. I'm not going to discuss. Don't worry about it. The important concept I'm discussing the important concept. In the previous two cases, we are using finished goods. We are buying the finished goods. The sense like soap, simple items. All things are already manufactured somewhere, and then they're put in the online store, or maybe they're putting in the offline, your grocery store. You're going to buy the wholesome product. You're not going to do any manufacturing, or you're not going to do any processing, right? So here production model is nothing but you have it's not finished. You have a manufacturing company. Let's say you are having your own company. Okay? Let's say you are a bread manufacturer, right? You're a bread manufacturer, let's say. So you are not going to buy that bread outside. You're going to use it daily. Let's say we are a bread eater and we're eating daily, right? So now this is quantity Q, obviously y-axis, and this is your time T. That's good. Okay. So let me break all these things in different parts. Okay. The first one is nothing but this is the quantity Q. This is the quantity Q that you have to produce for each order. Each order in the sense for each cycle. In a single year, you won't do in a single thing. You will do it in a cycles, right? You will do it quarterly, or maybe you'll do half yearly, or maybe you can do twice in a quarterly. It doesn't matter. So this is a single cycle. For each cycle from O to B is one cycle. This is one cycle, production cycle actually. So if at all you are trying to produce this much quantity, and you are saying that I can use that quantity in certain time T. And that's the reason why this violet color line is production. Why it is increasing? Why it is increasing here? Slope is increasing because you are producing it. You're producing it. You're producing it. So you have to produce till this point. You have to produce this till this point. And as you're producing it, consumption is happening. As you're producing it, consumption is happening. Producing it, consumption. And at certain point, production will stop. And obviously, please remember, the production rate is more than the consumption rate. If your production rate is not more than the consumption rate, you can't use it, right? Obviously, you're eating 10 breads per day. Let's say you're consuming 10 breads per day. Obviously, your production should be more than that or equal to that. You have to produce 12 or 13 or 100, 200, I don't know, but you have to produce more than 10, right? So that is the reason why slope of K is more than B. Slope of K is more than B. Production, consumption. Production is going up, consumption is coming down. Okay. Now, so at certain point, you have to stop production because you are producing faster than consumption, right? So once you stop, whatever the produced things that are there after consumption, that is your maximum inventory, and then from there the inventory will start. The inventory will not start from here because you're producing, consuming, producing, consuming. At some point, you stop the production, you reach the maximum production, and you stopped it, and some quantity is left because till this point you consume something. Till this point you consume something, so the quantity has reduced. So this is the point at which you stop the production, and your consumption is only through inventory. So this is the place where the inventory is taken care of. Okay. So this is the important triangle. So this is your K minus D. If you are joining from here to here is K minus D. Production minus demand. Production minus demand is joined till here, and from here the consumption is happening. So the same K minus D and D, K minus D and D cycles will be keeping on repeating. If you are taking this, K is production rate, D is demand rate, and T1 is production time, and T2 is only consumption time here. So T1 plus T2 is total time. Okay. So the important formula EOQ is given as like this. That is, don't forget about all these things. EOQ is nothing but, you know already the formula of EOQ is under root 2D C0 by Cc. The only multiplication factor that is coming to picture is K by K minus T. Production rate minus by production rate minus demand rate. Important formula again. At least remember this formula. Sometimes problem. Nothing but you have to pick the right formula. Production is allowed. 2D C naught by Cc is simply EOQ. You have seen in the Wilson-Harris model, in the first model. This is third model, that is production model or build-up model. Into K by K minus D will be coming to picture. K is production rate and D is demand rate. And also they might ask, what is the maximum inventory that is achieved? What is the maximum inventory that is achieved? QM. The maximum inventory that is achieved is nothing but K minus D by K into Q. Q is nothing but that quantity that you have to produce. This is the quantity Q. This is the inventory quantity Q. This is the inventory quantity Q. This Q star and Q are same. Q and Q star are same. Okay. So once you find the Q star into K into K minus D by K, you will get the maximum inventory level. This can also be a question. Okay. Fine. So this is the inventory cost. So at minimum at optimum inventory quantity, so you have to find out the cost. So already you know that 2D C0 into Cc under root 2D C0 Cc is your inventory cost in the Wilson-Harris model or the economic auto quantity model. Here another multiplication factor is K minus D by K. So just it is a flip, you see. For inventory EOQ, you are doing K by K minus D. For total cost, you are doing just flipping inverse K minus D by K. That's it. Okay. So the important formulas that you have to remember in this two slides are nothing but these things, this thing, this thing, and this thing, this thing. Very important points. And then this thing. Very important. Okay. So, and in the previous slide, in Wilson-Harris model, what I told, it's nothing but the carrying cost, the ordering cost is carrying cost. Here, instead of carrying, we are getting, instead of ordering, we are getting setup. I told you already. Ordering cost will come for fully finished, finished goods. So we are setting up a manufacturing. That's why setup cost is equal to carrying cost. That's it. That's it. Fine. So this is the formula and all we are using it. But let's solve this problem. Let's solve this problem. What is that? In a machining shop, pins of 15 mm diameter are produced at 1000 per month. What is this? Produced at rate of 1000 per month. What is this? Is it D, Q, K? What is that? Anyone? K. Obviously it is K. Produced. K. K is how much? 10,000 per month. Good. And it is consumed at 500 per month. What is 500? Consumption rate. What is 500? Tell me. Is it not D? Consumption rate or demand rate? Yes or no? Is it not D? Yes. The production and consumption continue simultaneously till the maximum inventory. Obviously, I told you already, production consumption is until unless maximum inventory is reached. Some QM is reached, Q max is reached. Then the inventory is allowed to reduce to zero due to consumption. Obviously, I told you after maximum inventory, it is inventory that is coming into picture. The lot size of production is 1000. The lot size of production in the sense, and in a single lot, 1000 you're producing. 1000 you're producing. In the sense, what? What is that? What is that 1000? What is the sound 1000? Is it not Q? Yes or no? Is it not Q? For that cycle, they are trying to produce 1,000 pins, and they're asking Q max. So Q max is nothing but we have seen already the formula, that is K minus D by K into Q. So what is K? K is 1000 minus D, that is 500, minus divided by K, that is 1000, into Q, that is 1000. Right? 1000 is cancelled. 1000 minus 500, 5000 minus 500 is 500. Answer is 500B. That's it. Simple question. Where did we see this formula? In the previous slide. This was the formula. Yes. So let me erase this thing, and this is the solution. This is the solution. Right. And Yeah, shortage or stock out, very important. Here also, now shortage is allowed. Slowly we are increasing the complexities. Shortage is allowed now. What is shortage is allowed? Shortage is allowed in the sense like you're going negative, going into negative. So this is where the shortage is happening. At T2, the shortage is happening. Okay. So T1 is the time the consumption is happening. T2 is the shortage is happening. Right. So total how much quantity? This is the quantity that you have to order. Why sir? Why sir the quantity? Because you have some quantity, you're reducing it to zero, and you have to cover the shortage, and then you have to cover the next cycle, right? So that's why you have to order Q quantity. That is what, how much is the order Q, that for this we have to find, sorry, for this we have to find the optimum Q star. Okay, so what is the quantity that is for maximum inventory? Maximum inventory is nothing but Q by Q minus S. Maximum is Q minus S, quantity that you have to order in each order minus the shortage, this is shortage, is Q minus S. Okay, so you see T1 is nothing but time required for each inventory consumed. T2 is nothing but shortage or stock time. T is the cycle time. Fine. And here total inventory cost is, initially we have written ordering cost plus carrying cost, but here adding extra, that is shortage cost. So already we know that D by Q into C naught, and this average inventory into CC, and this average shortage into CS, right? So we have done some formulation and all stuff, and we have found out that this is what is important. Q star and TIC are important. That is 2D C naught CC, we know, we have already seen that, and 2D C naught by CC into K by K minus D is for production model. This is your EOQ for production model. But in this case, it is shortage cost per unit per time into carrying cost per unit per time divided by shortage cost per unit per time, right? CS plus CC by CS. And minimum total inventory cost is 2D C naught CC, we already have, into some multiple, this reverse of this, flip of this, that is what is this, CS by CS plus CC. Okay. Like that, initially we have seen that the maximum inventory Q is like, what is that, K minus D by K into Q, we found it for production model, right? Like that, for maximum inventory we have to use this formula, that is Q star minus S star, that is M star. M star is nothing but Q star, that is EOQ, into CS by CS plus CC. So this is the formula that you have to remember. So what are the formulas that you have to remember in this model? This one, and this one. So if you want, you can take a snapshot of this, or maybe you can revisit the video and then take the snapshots, or maybe you can pause the video and you can write the formula as well. Okay, very important formulas. Now let's solve this problem. What they're saying, a company has an annual demand of, what is 1000? What is 1000? What is 1000? What is 1000, guys? Hello? Yeah, D is equal to 1000. And ordering cost of, what is this? What is this 100? CO is rupees 100. And carrying cost, that is CC, is equal to rupees 100 per unit per year. And if the cost stock out, what is this? What is this? No. The stock out costs are estimated nearly rupees 400 per each item. But stock out means shortage. Is it not CS? Yes or no? Yeah. The safety stock carried, justified by carrying cost. Safety stock carried by justifying this. Safety stock is what? M star, maximum inventory, they're trying to find out. M star is nothing but Q star minus S star. And that we have seen that in the previous class, Q star into something CS plus CC by CS, something we have seen, right? The formula, is it the same formula? CS, the formula is this. Then you found out Q star first, then you found out the M star. M star is 40. That's it. Is it clear, guys? Yes or no? That's the end of your inventory models of the deterministic. So we have discussed 4 models. What are the 4 models? First one is simple UOQ or Wilson-Harris model. Second one is your price break model, right? Simple price break. What if price break is there? Then next, if we have production model, right? Production model, and then we have discussed about the shortage model. So these are all our deterministic models where demand rate and lead time are fixed. Right. Next, demand rate and lead time are not fixed in probabilistic model. Right? In probabilistic model, of course, demand rate and lead times are not fixed. So obviously, if you see in the cycle, same demand rate and lead time are there. In the cycle, say lead time is changing, demand rate is changing. So demand is suddenly changing, lead time is going to shortage. So during the shortage, if you see the safety stock is there, already there is a buffer stock, safety stock, some buffer is there. So during this time, the quantity from the safety stock has been taken. This is where the safety stock has been utilized. This is where the safety stock has been utilized. I'll tell you. So this is where the safety stock has been utilized, right? And then sometimes if something has happened, so there's less quantity that has been consumed. So there's no problem in this. There's no problem here. The only problem occurs in this case. The only problem occurs in this kind of case. Is a problem. This is your problem, right? So that's the reason why you're carrying the safety stock. That's the reason why you're carrying the safety stock. So if you see the ADT that is what is your nothing but average demanding. Why it is average now? Because this demand, everything is different. So that's the reason why we are taking average demand during lead time is ADT. And if you are seeing what are the factors that are important for higher safety stock, when do you carry more? When do you want to carry more and more safety stock? When the demand rate and lead time are having high fluctuations. Suddenly anything can happen. Suddenly people are asking for the mobile phone, or suddenly people are asking for so and so and item without with some reason they're asking, or maybe some strikes and all are going. Your delivery is not happening on times, right? If you might have seen in the COVID situation what happened. You wanted to order online groceries, but due to hoarding, what happened? More and more online orders have been delayed. Big Basket, Amazon, whatever it is, they said that if you're ordering now, it will come in 3-4 days, but it might not be guaranteed, right? So anything can happen. So then you have to have more and more safety stock with the persons. Next, inventory and holding cost is less. So you have less inventory cost. Let's say the shirt and t-shirts and the trousers you're carrying are very light in weight. So there's no point. The cost is less, right? And sometimes shortage cost is not uh, uh, shortage cost is very high in the sense like uh, you're losing so much profit. Let's say your mobile guy is coming to you and asking for mobile, you're not providing it. For that you are getting huge margin. So you don't want to lose that. So if you don't want to lose that, you have to carry more and more safety stock. Next, number of orders in year are more, fluctuations are more. For providing good customer satisfaction, this is a very important point. Obviously, if somebody is coming to your shop and asking for something, if you are saying yes, that's a good thing. If you are saying no, that's a bad thing, right? So if you are saying yes, the customer is satisfied, there is no problem with that. That's the reason why you have to carry more and more safety stock. Fine. So now reorder level here is not here. Initially, we had a reorder level here. You remember this was lead time here, and this was reorder level. Now here we are carrying a safety stock as well, right? So this is what is safety stock, right? The safety stock is this. So reorder level is nothing but safety stock plus average. This was average demanding load. If you remember, this was ADDLT. You see in the previous graph. Okay, I'll show you in the previous graph. So reorder level is this. That is ADDLT plus safety stock. That is what I've written in the previous slide. The next slide, sorry. So ADDLT is nothing but lead time into demand, and average inventory can be written as Q by 2 into SS. In the previous slide, when we were discussing about these things, so this is your maximum, and this is your minimum, and this is your Q, this is your 0. We told that average is nothing but Q by 2 we have written, right? But here Q by 2 is nothing but here we are having safety stock, right? So this is I have Q averages Q by 2 plus safety stock. That is what you have to add extra. Okay. Now, so let's discuss these models, these two models, demand profit model and the what you say, the service level model in the tomorrow's class, and wind up the inventory control, and then we'll start the linear programming, that is your operations research. We'll be discussing graphical methods, we'll be discussing transportation models, assignment models. All these things we'll be discussing in the coming lectures. PERT and CPM, all these things we'll be discussing. Okay. So as of now, we'll stop the presentation in the class today for now. If you have any doubts in this, because I am doing a little faster because we have to complete so much syllabus is left, industrial engineering is left, and we have to complete all the models in inventory, I mean this, what you say, the operations research, and then we have forecasting, we have sequencing, and then we are left with metrology inspection as well. So let's come, we have limited time, so let's complete that as soon as possible in the coming lectures. Can you show me last third slide from here? Is it this? This one? This one? Yeah. Okay, anyways, like I'll stop the recording. If you have any queries, please ask me.